This is assignment 1 of research methods, starting with quantitative and qualitative data. Quantitative data is a collection of numerical data that is presented in a systematic format. When collecting quantitative data, the researcher is trying to find a relationship between two common factors. For example, the height of basketball players and the number of points scored during a game. This type of draft usually has a hypothesis to start with and collects data in a statistical or mathematical way to then prove the hypothesis. This is used frequently within sport when researchers are trying to find a reason for a certain outcome or behaviour. For example, they may hypothesize that more hours a week a football team spend with one another, the more games they win. Researchers would then collect sets of data and compare the relationships. For example, when teams spend more hours together, they win more games. Qualitative data is a form of data that takes a more methodological approach to data. It's based around words, opinions, and feelings, rather than quantifiable information like numbers and facts. Instead of looking for a relationship between two factors, the data aims to find a secure explanation for why something may occur. For example, in sport, a researcher may want to know if children find one sport more enjoyable than the other, and why, or even to try to explain why certain children don't enjoy sports. This data is so broad that it shows many paths a researcher can choose to follow, meaning at the start they may not know what they are looking for. This data usually has more depth to it, and the end hypothesis isn't usually determined until partway through the research. It is used in the earlier stages of research to help highlight key areas that may be of interest to the researcher. It can be done using group interviews or even observations, and then moving into singular interviews. It's entirely based on opinions, views and feelings of the participants, which in this case would be sports-related people. For example, conducting interviews with participants about how they feel about women taking part in contact sport. This could lead to why women feel intimidated in male-orientated sport, if that's what participants start to discuss. This data is known to go more in depth into research, but is argued to be less accurate because it means data collected can be interpreted in different ways by different people. Reliability. Reliability is having the reputation of being trusted or being consistently accurate within a field of knowledge, and meaning the test can be repeated easily and the same results be obtained. When researchers use other resources to back up or base their hypothesis results, they must ensure that the sources they use are reliable. This can be done by checking the credibility of the author, for example, seeing if they are qualified to comment on the topic they wrote about, e.g. qualifications in sports nutrition when writing about the effects of carbohydrates on marathon runners. If the author isn't reputable, then the article of the source has less reliability because it's considered it wasn't written within the correct knowledge. Also, the source may be biased and then show both sides of an argument equally. Another way to see if a source is reliable is to check the date it was collected, or did they use an appropriate method. For example, when researching how many people watch football on a Saturday, but use a questionnaire to collect the information, when it could be argued that an observation is a more suitable way of collecting the information. This is known as internal reliability. It's when results within the test are consistent as well as how the data was collected and interpreted. Without these things being consistent, there is more chance of an error for a human error. This type of reliability is known as external reliability, and this is measured in how drastic the results differ from one researcher to another. For example, if the test is repeatable and when repeated the results obtained are similar to the previous results, the tests have higher reliability. When using other resources, it's important to check the results they obtained were similar to the results obtained by other researchers, preferably two or more sources. If not, then there could be a fault within the research. Having high reliability means that results you obtain are more trustworthy and less likely to be biased. It also means that people are likely to accept your findings as credible. Making sure that the source you use is reliable will also improve reliability, which making the outcomes more reputable. Having poor reliability could result in there being incorrect data within your work. For example, you may use a source that it was biased because you didn't check its reliability. This would then reduce the reliability of your work as you used a biased source, and then making it incredible or trustworthy. Tests that have low reliability usually have certain issues such as human error, which are errors that occur due to humans, or miscalculation or negligence, or potentially the test length, meaning the test that goes on for more time than necessarily may have more anomalies within the results. Validity. Validity is whether the data you're collecting or tested being carried out is relevant to your hypothesis. When undertaking an experiment, there is an independent variable which should be the only variable in the experiment being manipulated or affecting the dependent variable. For example, whether fats or carbohydrates are better for marathon runners, the independent variable is the different macronutrients. This is internal validity of the test as it relates to the immediate effects of the experiment. When the results of the study are a result of anything other than the independent variable being manipulated, then the results are then the validity of the results lower. For example, participant within the marathon running example taking energy capsules whilst taking part in the experiment. Having high internal validity means the results are related to the hypothesis of the experiment, and this means that the test fits which the hypothesis to produce the expected results. For example, the test shows them what macronutrients provide the longest lasting energy for a marathon runner. External validity relates to whether results from the experiment can be applied to the larger population and generalised. This can be known as ecological validity, meaning it can be applied in another setting. Population validity can be applied to other people within the target population, and historical validity can be applied over time. Having high external validity allows the results to be applied to the real world and having a greater effect on the target population. For example, discovering carbohydrates give marathon runners longer lasting energy can be applied to long duration sports such as triathlon in 1500 metres. This then gives the test population validity. Because it can be applied to others. Having low external validity would be obtaining results that have no relevance to what you're researching. For example, discovering marathon runners live in cities compared to the countryside. This isn't going to improve the marathon runners' performance as they still complete the same training. External validity can be improved by making the experiment have more natural settings instead of a lab setting. Also, using a random sample will mean that you're more likely to represent the whole of your target population. For example, using a range of different ability marathon runners, having them train within their own environment instead of an unfamiliar place like a lab. Accuracy and precision. Accuracy is known as the degree of which results conform with known knowledge or statistic. This means that a result can be accurate but only to a certain degree. So one result can be more accurate than another. For example, in sport, measuring a 100-metre sprint using light gates is more accurate than using a normal stopwatch because it is closer to the correct value due to its ability to react faster than a human pressing a stopwatch. Using more accurate results increases the researcher's reliability. This is because researchers are more likely to produce similar results when repeating the investigation. The closer your results are to the true value, the more accurate they are. If your results come back and they are inaccurate, then it is an indication that something went wrong within your method when it was carried out, or that there is an anomaly within the results. Precision is linked directly with accuracy, reliability, and validity. Precision is whether an investigation can be repeated and produce the same or similar results due to systematic method. For example, results that are similar or close together are more known as precise. When we have higher accuracy and directly linked to precision, as your method and approach are consistent and accurate, then they most likely will be precise apart from anomalies. This is because the same process has been used each time. An example of precision is when interviewing someone about how many hours they spend doing exercise. Use the same equipment and questions. It also links to the reliability and validity, as the method isn't repeatable and the different results will be found each time, and if your measuring isn't relevant, they will be invalid. It is possible, however, to have good precision and low accuracy. This can occur when you carry out a method systematically and consistently, but there is an error within the method. For example, consistently asking about carbohydrates intake when you're researching fat intake of children. This results in the data being precise but inaccurate, as it is far away from what you wanted to know. Ways of collecting information and data. Interviews are a way researchers can collect data from participants. They're usually looking for qualitative data, as they rely on participants' feelings, opinions, but they can also be quantitative, depending on what question is asked, e.g. a yes or no question, closed. There are 3 types of interviews: structured, semi-structured, and unstructured. Structured interviews follow a set order of questions that were predetermined by the researcher. They aren't flexible, meaning no other questions are asked except for the ones listed, and the interview follows a strict order. These types of interviews have high reliability and validity but low quality of data. Semi-structured interviews only have a guide to follow, meaning subjects to talk about, etc. These interviews look for more in-depth answers from participants and are flexible, meaning they can be asked to explain from the researcher. This means that more in-depth information is brought out of the participant and maybe explaining into further detail why or how. Unstructured interviews are completely flexible, as they are less formal. They only contain a starting question to ask, and from there the researcher and participants are free to talk about whatever. This can result in the data collected being irrelevant or invalid to the investigation. However, it produces a more in-depth result and is most likely to be in the qualitative form. Strengths of interviews include that they allow people to express their views, they can unearth unexpected data that would be useful, and information other than words can be indicated, such as tone of someone's voice or their body language. Weaknesses include they can be time-consuming, analysing the data can be difficult, and and quality of the answers can have an effect on the result. Focus groups are another type of interview, but involve 6 to 12 participants being interviewed at one time. This means each group gives a generalised answer to each question, and also it can create meaning for discussion and debate, which can show a stronger answer and help the information being collected be more detailed and in-depth. This mainly collects qualitative data, as the group generally decides how the conversation flows. Strengths of focus groups are that they create a deeper discussion between participants. Most people feel more confident to talk in a group setting, and body language can indicate feelings and emotions. The negatives of focus groups are that some participants may not give their view or opinion due to feeling pressure or the need to conform to the rest of the group, and they can also be time consuming and data can be hard to analyse. Observation is when a researcher purposely watch participants in an environment or situation and take notes on things like behaviour, reaction to something, or potentially participant reaction. This is mainly used to collect quantitative data, for example, counting the number of people that turn up to a Sunday league match. One type of observation is notational analysis. This is when researchers look at the pattern of play or tactics used by players to gain an advantage. This can highlight more popular tactics within a game and also identify what works and what doesn't. Another type is coaching observation. This is when specifically coaches observe the player's performance and pick on weaknesses or lack of technique so that overall performance can be improved. This can be done so that even the slightest improvements can make a player's performance increase. Finally, researchers use participant observation or non-participant observation. Participant observation is serving from the outside of a situation. For example, investigating cohesion in football, but being part of the football team to see who get on and who don't. Non-participant observation is not being actively involved within the observed group. For example, observing the amount of failed passes in a football match from the sidelines. The strengths of observations include that they're in their natural setting, which increase reliability and validity of the research, and also data isn't based on recall, it can be recorded at the time of being observed. The negative of observation include that the research could be biased based on researchers' views, and the data can be hard to record or classify, and may be unreliable if the method isn't reputable. Questionnaires are used by researchers to collect information from participants quickly and effectively because the same questions are asked and many can be done at once. There are two types of questions, open and closed. The type of question used in a questionnaire can lead to the type of data collected. For example, closed questions are usually yes or no answers and don't go into depth about the participant's opinion, meaning they collect quantitative data. An example of a closed question is, do you play football? Whereas an open question asks for an explanation from the participant and leaves them to go into more detail. This results in qualitative data being collected. An example of an open question is, why do you think girls don't play as much football as boys? Explain. The strengths of questionnaires include you can have a big sample size, they're straightforward and they're easy to set up, and this makes them quick to complete. This means large groups can be questioned and data recorded in a shorter amount of time. The weakness of questionnaires include that people could lie on them, they lack external validity, and they can be hard to follow up if anonymous. This could result in the researcher being unsure if the data is useful or even valid to the research. Finally, lab-based and field-based data collection. Field-based data collection is collecting data in a natural environment or environment that stimulates the real one. This means that you are testing in a natural environment like real life, which results in the research being more generalizable to the real world, but may have a lower reliability as you cannot control the factors. An example could be observing the performance of a footballer after 8 hours sleep compared to 12 hours sleep. Other strengths of field research is that they have high ecological validity, meaning they're more likely to be like real life situations. They are cheaper to run and easily accessed. The weakness can be that they have low internal validity, as not all factors can be controlled, meaning that other factors could affect the dependent variable, and they are also hard to repeat. Field-based collection is collecting data in a natural environment. So, it means away from a lab situation. Lab-based data collection is when the experiment or tests are done within a lab where all variables can be controlled, such as the temperature, fluids, or even the conditions of the environment. An example of this is having a marathon runner run on a treadmill connected to an oxygen mask and having consistent obs done on them to measure their energy production within the working muscles. Being able to control all of the factors within increases the internal reliability and internal validity of the test, as there is no other variables affecting the dependent variable. However, it loses external reliability and validity, as is less likely to be generalised to the real world, as we can't control the temperature or conditions when out doing this in real life. This means that it can only be used within the lab, and the data could just be completely invalid as it can't be used anywhere else. However, lab-based data collection means that is more repeatable and the results can be obtained in a better light, but the negatives can be that it's more expensive, is harder to access, and that without this certain equipment is almost impossible.